Hi everyone, Mr. Boltri here bringing you video 2.2 where we're going to be talking about the Buggy lab, which is the lab that we're going to run in our next class. So like with the last lab, the M&Ms lab we did, I'm going to show you a setup and then ask you the question, what can we measure? So we have this little Buggy here and I'll show you what it does. But as you watch this little video, I want you to think to yourself, in this situation, what is it that we could measure? So you can see the Buggy, there's a little switch on the side, you can turn it on and put it on the ground, and it just sort of like coasts along. So that was it, and that's the lab that we're going to do in our next class. But now we have to figure out, well, what are we actually going to do in the lab? We have this Buggy that we're going to investigate, and what are we going to investigate about it? So there's sort of a two-part question. What can we measure? There's a lot of things we could measure, and what do we actually want to measure? So I'd like for you to right now think about what, if you were to design the experiment, what would you have be your independent variable and what would you have be your dependent variable? So we get a lot of options in terms of what we can measure. These are some of the most common answers that I see, but if you have answers that are not on this list, that is cool too. There's so much in this situation of just like the very simple little Buggy that we can measure, and then it's our job to agree as a class on which two things that we are going to measure. So of this list, I've organized them into 4 different groups. We have the mass of the Buggy, the weight of the Buggy, the dimensions of everything. And so those, I'm just going to go ahead and say I'm going to eliminate them because they're not going to be interesting if we measure it, because as the car moves along, the mass of the Buggy doesn't change. None of these change at all. So it's not going to be a very interesting experiment for us to do. In terms of speed, velocity, acceleration, I love the way that you're thinking about those. But unfortunately, I don't have my radar gun, so I can't measure the speed. And maybe you could calculate the speed if you do remember the formula. But remember, right now we're focusing on measurement, not calculation. So unless everybody has a radar gun they can bring in from home, we can't measure the speed. And my accelerometers are broken too. So these we're going to eliminate because we cannot measure them. So then if you remember from the vocabulary video, we might be interested in something like distance, displacement, or position, because as the car is moving, all of those are changing. The distance, displacement, and position are all changing. As well as the car is moving, the time is changing too. If we were to look at the clock, every couple seconds, the clock reading changes by a couple seconds. So it might be an interesting experiment if we could choose one of these green ones and choose one of these blue ones. But the graphs might look a little bit different depending on which one of these we choose. So if one group chooses distance traveled and another group chooses position, their graphs might look different. So just to make sure that all of our graphs look pretty similar, I'm just going to say, let's go ahead and say the position at a bunch of different times. So right now the position is here. Right now the position is here at a bunch of different clock readings. So that's going to give us all the same graphs, and I have a feeling that it's going to give us some of the most interesting graphs of any of the options here. So I'm just going to narrow it down for us and say that the thing that we're going to be investigating for this lab is the relationship between the position of the cart and the clock reading. And sometimes I might just, instead of saying clock reading, I might say time, and that's okay. Just everyone know that I'm talking about the clock reading. Just look at the clock and read the time right off the clock, as opposed to like a time interval. We just want the instant right then and now. So now what I'd like for you to do is to grab your lab notebook and flip to the next available page and title it Buggy Lab, big at the top, because it's going to be really important for us to be able to move efficiently in our next class is if we already have the lab set up for this lab. So the lab setup is going to be the same as all our lab setups in the past. We're going to fill out everything on the left and make sure our data table is ready to go so we can fill in the data table and then just hop right into the graphing and analysis in our next class. So the question is the one that I said just from the last slide, which is what is the relationship between the position and the clock reading for the Buggy? So we're going to have to make a sketch. It should probably include the Buggy and something to measure the position and something to measure the clock reading. So to measure the position, well, our room has a lot of nice tiles in it. So we could bust out the meter sticks and sort of like mark off how many different meters there are. But the tiles is a really convenient way to just figure out, well, what is the position right now? It's 1.5 tiles. So we're just going to use the tiles to measure the position, and a stopwatch is a really good and easy way to measure the clock reading. So make sure all three of these things make their way into your sketch because they're all going to be important for our lab. So for the procedure, I'm going to ask that you write your own, just like I did last time, because one of the important things that we are practicing in this class is writing experimental procedures and setting up our experiments. So I don't want to do this part for you, especially because it can be kind of interesting. Some people choose to make position their independent variable, and some people choose to make clock reading their independent variable. And either one of those is correct. I'm just kind of curious how you're going to set it up. Make sure you don't have to write a whole essay here, but make sure it's very clear what you are measuring and when. So don't just say gather data, say what you are measuring, how, and when. So be very clear in your procedure, though it doesn't have to be super long. And then last but not least, we're going to have to set up our data table. So make sure you have a space for the time, which is going to be measured in seconds, and position, which is going to be measured in tiles, and have at least 1, 2, 3, 4, 5, 6, 7, 8 data points at least. There's also 2 constants, which I'm going to give every group a different one of these constants at the beginning of the lab. So leave a space for me to give you a starting point and a direction. And we'll talk more about what exactly I mean by that at the beginning of our next class. But I just think this lab will be more interesting if different people start in different places and move in different directions. I just have a feeling that that's going to give us more interesting results at the end. And so you might say, well, Mr. Boltri, that's not a fair test. Well, as long as, let's say I give the green team a starting point and direction, as long as the green team stays consistent the whole time, then that's a fair test for the green team. And then if all the groups are doing fair tests, then we can compare all those fair tests with each other and see how the results are different. And hopefully that yields some interesting discussions. So I'm so excited to do our Buggy lab in the next class. Make sure your lab notebook is all set up and ready to go so that we can hit the ground running and do the lab and get the data and analyze the data all in our next class. So we have a 75-minute block, so it should be plenty of time, but make sure you come in with your lab notebook all set up. So I'm looking forward to seeing everyone next class so we can do the Buggy lab together. As always, let me know if you have any questions, and go Bears.